Yeah. Hi everyone. Good evening from Vietnam. Yeah. Hi Arihan. Hi Subteam Vietnam. And I'm Satama Koder, the builder of Kachi Host. And also uh, a super team member. Yeah. I also your host for today's session. And web. Yeah. Hi Suri. Welcome to our workshop Encrypted Data by Arcium, collab with Team Vietnam. And the goal of today's session is to help more builders from the Team Vietnam community understand what Arcium is and how encrypted data computation work and how we as developers can start integrating it into our Web3 project. Yeah. We will start with an introduction to Akim from Arihant, and then I will do a short demo showing how to encrypt, upload, and decrypt data using the Akim SDK. Final, I will share a bit about my project, Kajuhood, and how I see Akim fitting into privacy preserving education app. And so let's get started. And please feel free to drop your question anytime during the session. Yeah. And
Yeah. I'm going to present my
share the
screen.
screen. Yeah.
Yes. Uh, uh, uh,
Yeah.
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 Hi, guys. I'm Arihant. I'm an ecosystem engineer at Arcium, and I've been with the team for a couple of years. Today, I'm going to be talking a bit about what Arcium is, how it works, and then I'll give a brief demo of how the developer experience and the developer workflow of building with Arcium looks like. So, for those of you who don't know, Arcium is yeah. So what we're trying to do is what our goal is to try to have to encrypt everything and to be able to still compute anything, right? What does that mean? So what we're trying to build with Arcium over is what we call the encrypted supercomputer. Um, the problem being that everything on chain is public right now, right? Every swap you make, every transfer you do, every action that you take on any app on Solana is public. But something should be private. I'm all for transparency, but at the same time, you don't want people to know every single step that you take in your daily life to be public. If we consider that businesses are going to be living on chain, or even that most of the world's finance will be on chain, that cannot happen if everything is public, because there are things wherein people have slight information advantage or just don't want others to know what they're doing, right? So for such cases that we need to have some sort of privacy on chain. So we've had this talk about privacy in crypto for a long time. Earlier, it used to be called known as Privacy 1.0. So back in the day, this was basically financial and transactional privacy. So um, it was things like, Zcash, Monero, Tornado Cash. You might have been hearing a lot more about these things recently. So we like to categorize these as Privacy 1.0. So basically, just financial and transactional privacy without any encrypted shared state. Now, that's the most important point here, is that there was no encrypted shared state. So what does that mean? So that means is that I was able to transact privately. I knew my private balance. I was able to transact with my private balance. Similarly, you could do the same, but we could not collaboratively come together and modify or work with a single piece of encrypted data. Because if you consider what your usual actions on chain are, a lot of things what you're doing are not just data which you own, but also data which others collectively own. So things like AMM pools, right? When you swap through an AMM or you LP into an AMM, you're not the only one interacting with that given piece of state on chain. There's hundreds, if not thousands, of people interacting with it. Privacy 1.0 did not have the ability to provide encrypted shared state, which is the backbone of what is needed in order to unlock the entire realm of possibilities when it comes to privacy. Privacy 2.0 is the new generation of privacy which enables this encrypted shared state. Here, everything can be encrypted and still anything can be computed upon that encrypted data without needing to decrypt it. This leads to a lot more powerful application and leads to a lot more composable privacy at every part of the stack. And this is basically what we're trying to build. So what it would look like for an end user, like what applications you can build, or basically there's endless applications, but some of the most popular ones would be with respect to DeFi, you can build confidential markets. Now, confidential markets can be spun up as dark pools, which are basically a completely encrypted order book. So no one knows what you're trading or how much you're trading, things like that. You can have private lending borrowing protocols. Now, the additional advantage of these confidential markets is that you have complete MEV protection, since no one can see your orders, therefore no one can front end you, coin sandwich you, right? So these are just the tip of the iceberg of what it comes to privacy. Um, there's also applications in AI with respect to confidential trading, trustless autonomous agents, end-to-end encrypted AI, inference, things like that. And this is basically what we're trying to build. Now, what I want to talk about is primarily how we do this and how the entire flow works for a developer's point of view. So we use a lot of cryptography, primarily secure multi-party computation, which allows us to jointly compute a function over distributed private data while keeping sure that all the inputs remain public. Nothing can be decrypted unless the user specifically asks for something around that, right? So that's basically it. Uh, our, our motivation while building Arcium is that you, as a developer, do not need to know any of the cryptography and still be able to, encrypt and compute over encrypted data to integrate privacy into your applications without having any sort of cryptography knowledge. So this, you don't really need to understand how we do it. All you need to understand is how the flow works and how you can build with it. So the basic data flow is that all data is encrypted on the client side. So here, as we can see, encrypted data. So on the client side, we have some data we encrypted, and now we have this encrypted data. This encrypted data flows into the Solana program that the user has written. Okay. Now you, as a developer, write a program. These are the input. There's some encrypted state related to this program. Now your program calls the Arcium program. The Arcium program then schedules a computation to be done on top of this encrypted data. And once that's scheduled, the Arcium network basically takes that data, transforms it into what's called as secret shares for each of the specific nodes to compute on it. So as we previously said, the nodes jointly compute a function over distributed private data. So they're jointly computing a singular function over distributed data. So they have different key shares of the same data, secret shares of the same data, and they compute jointly over that. And then you get back the result. Now, the result can be some encrypted data, some public data, or even data encrypted to a third party, which is useful for things like basically private data sharing in a trustless distributed environment without any third party knowing what it is, right? So I can technically share my data with you without any third party, any onlooker being able to see what that data is, right? So this is basically the flow of how Arcium works. And yeah, I mean, this goes into a bit more complicated things, but yeah, that's all you need to know when dealing with Arcium. And Arcium is one of the best ways to build up privacy because it's security against dishonest majority. So it's the relatively most trust minimized practical implementation of privacy possible to be, right? So we only require one honest actor in the entire set of cluster to make sure that your data remains confidential. You get your security guarantees. So that's basically it. I'm not going to spend more time on theory. So now let's go on to understanding how Arcium works from a developer's perspective. So you can go to docs.arcium.com and then go to this developers page in order to see and understand how the developer tooling works, how to use it. So basically how it works, as I explained previously, was your client encrypts some data, sends this to an MXC program. Your program submits the data to Arcium's network of MPC nodes. The nodes process the data while keeping it encrypted and return you the results. That's it, right? What you need in order to get started with Arcium is all you need to do is copy this command, paste it in your computer, or it checks what your operating system is. It downloads our version manager, it downloads the relative relevant tooling that's required, and you will basically end up with all that's needed. There are some prerequisites that you need, but this takes care of those as well and lets you know that if you don't have something, you can install it then, right? So how does an Arcane program look like? Like, what do you do? So most of you should be familiar with Anchor. So if you are familiar with Anchor, Arcane tuning is going to be a breeze, right? It's basically our CLI is a wrapper on top of the Anchor CLI and basically has the same commands, just with some additional things happening underneath the hood, which are relevant for building with Arcium relative to just normal Solana programs, right? So when you do, you might be used to doing Anchor init. You can do Arcium init in this example. And when you do Arcium init, it basically creates the same folder structure as an Anchor project, just with two different things. One is an arcium.toml file, which is a configuration file for the Arcium tuning suite to run locally. And second is this encrypted instructions directory. Now, this is a very important part of the Arcium tech stack. The encrypted instructions directory, this is where all the code that is meant to operate on encrypted data, all the logic that's meant to operate on encrypted data goes. So the separation basically becomes that whatever logic you want to run on encrypted data, that goes out of your programs and goes into this file, and your programs call these functions. These are the computations that you schedule, right? So it looks pretty simple. It's just normal Rust. And yeah, so here we have a function which takes an input of encrypted data input values, which is just two U8s, and basically returns their sum, right? You can understand more of how it's going on. I'm not going to dive too deep into this. Next, we have how to interact with the Solana programs. You can go on, read about it, understand how it's all going. We have our own client SDK as well in order for to do all the encryption and any data fetching, things like that. And that's basically it, right? So our code is pretty straightforward once you get the hang of it. And it's not super complicated, relatively speaking, I would say. And it's the easiest way to get privacy into your applications. There's like, you basically don't need to know any cryptography. The only place any cryptography is shown to the user, or you write within your code, is basically this, which is I create a cipher and I literally call dot encrypt, right? That's all that is kind of exposed to you. Everything else we abstract it away, we deal with on our end, and you just write whatever code you want to. We deal with everything else. So we have this examples repo which is public, and here you can go in order to understand a lot of different ways you can deal with the Arcium tooling. So there's examples from confidential voting, wherein we basically hold a stat. We store the number of yes and no votes, encrypted obviously, and we basically increment them whenever user votes, and at the end we reveal the result. Right? We reveal the result as to whether yes won or no won, but we don't reveal what exactly were the votes or who the votes were given by. So it's a very nice and fair way to hold an election or a voting of any sort. Um, yeah, we also have like a lot of examples of games. So another thing we can do is we can generate randomness within NPC, which leads to this example for thing, which is coin flip. So we can just generate a random boolean and check that the coin flip is correct or not. Similarly, thing is used for rock paper scissors when playing against the house. So if you're playing rock paper scissors against a bot, all I can do is the player's move is what the player submits, and then the house move is basically dependent using random number generated in NPC. So it's kind of more secure than VRFs, and a good way to do this. If you guys want to have a look at a more complicated example, I would recommend looking at blackjack. This is a slightly more complicated example of how a real world game would look like. So now you can, for the first time, truly have um, a game of blackjack or even a game of poker on chain, um, which was not possible yet because you need to have privacy of your hand, of the deck, of the hand of cards that you are dealt, right? Because if anyone can see the hand of cards that's there on chain, then there is no point in playing the game. But here we can literally encrypt a hand of cards. We can use shuffling. We have native shuffling as well to shuffle the entire deck of cards and to make sure that the fair hand gets dealt. Um, yeah, that's basically this brief overview of how Arcium works. Does anyone have any questions? Wait, stop sharing. Any questions?
Yeah, you Ariane, have any question? Hmm. Okay. Um, yeah. Thank you, Ariane. If don't have a question, I will go to we will next session about um, live demo. Yeah, and in this demo, I will show you how developer can use Arcium educate to securely handle data from encryption, block decryption. Yeah, we will start with a simple piece of data, encrypt it locally, upload it to the Arcium network on DevNet, and finally decrypt the response securely. Yeah, and let me walk you through the code step by step.
Yeah,
Okay, I will resend. Yeah, now we will sure we install Arcium and Arcrop. Sorry. Okay, and Arcrop. Yeah, and now we will Arcium init G and BC. Yeah,
perfect name.
yeah. Okay, and wait a minute to install to init project. Yeah, now. mm, Okay, well, you now you must run an view. Okay, and when in this Arcium project, we have Anchor framework. Uh, yeah, and have encrypt. This is as follows. Yeah, and Arcium have introduced this in the previous session. In here, we encrypt. We will create some function to encrypt data and call it in um, your Solana program in here. Yeah, introduce. Um, don't worry, it's not zero. And introduce something about key cost. Mm, like, like that. It's a computation we want to perform adding to unit a number is written in trust and compiled into encrypted key cost. Everything computed here is end-to-end encrypted. Yeah, and now this program, yeah, this program uh, receive encrypted data and price is for the index is a multi-party execution engine to process. And we must have we must have to Arcium program macro in Rust India. Yeah, and now surely you must install Docker and run Arcium as not and Arcium as not to not uh, from Arcium. Yeah. Hmm. Now you run so test creator to run localnet so now in your computer and now you run Arcium test. Yeah, in here we call to Arcium from um, we init add together context and call it in function as together. Yeah. Mm, yes. So localnet the online and wait Arcium not to know. No. Uh, when you test successful on localnet, you will deploy on testnet. Yeah, and basic deployment. I could deploy cluster offset, K-pair, and PC. I usually using Helios RPC to deploy Arcium uh, project on the net, and this is a cluster offset. Yeah,
Saitama, I think your screen is not being shared now.
yeah. Oh, sorry.
I think your screen is not being shared properly.
Okay. Yeah, every, everyone can see it,
Yeah, I think it should be fine now.
and now you didn't. Yeah, I can deploy cluster offset and repair and RPC. Uh, oh, ABI RPC. Okay. The first, we must deploy program on .NET on Solana. Yes, and wait a minute. Okay, let's deploy successful. And the second, Arcium will create an SE account with program program ID. Yeah, you can check it. Then, so, mm, yeah, the transition successful. Um, can check it. The program of Arcium. Yeah,
Yes.
and now we will rem-
I thought your screen is not sharing again. I'm not sure what's happening.
sorry. Mm, mm, mm. Yeah, you must then install ABC. Uh, just then install Arcium Hack we the client.
Saitama, your screen is not sure. It's showing again.
Okay. Yeah, you see it.
Yes, now we can see again. Yes.
Yeah, and I am testing my program on .NET, and I guessed Y6 here. Yeah, it's successful, and I interact with Arcium on ZMBCs before, and yes, that's all quite easy. Yeah, and
Yeah.
next session we will talk about how to interact Arcium in my project. We will check with Kahoot is and everyone can fly it. Yeah. Now we run it and you can create a widget. Yeah, in here. And I created some question about Archeum and everyone can interact with it. Yeah. Why was the Archeum erected on the during story? Yeah. And now and I deploy it on .NET on Solana and okay. Um, oh, I answer not right. Think I can yes. One and one to the answer. And yeah, if you answer is right, you can have song. Yes. Okay. And everyone can join and answer some question in here and create some question in here. Yeah. Interact with IKEA on that net. Thank you.
Awesome.
And now uh, we will go to next session and now follow-up action about Archeum, development hackathon opportunity in the Archeum ecosystem. And yeah, similarly introduce Alex, head of marketing, and a broad interested at Archeum and it's a normal nomad and Harrier depth. Yeah. Um, please, Alex.
Hey guys, hope everyone is well. Good to meet you guys. Jumping in here a little bit late. A little about me. I am head of marketing at Arcium. Been here for 3 years, even before we were actually Arcium. Um, and yeah, just leading all the go-to-market community together with our head of community, Andy, and trying to bring the Arcium brand and project and all the products and ecosystem teams to the forefront of blockchain and Solana for now. So really excited to be here. Um, if you guys have any community related questions or you have questions on how to get involved, please reach out or drop them in the chat. We can go through them. Um, just so everyone knows, we have a few things happening at the moment. For devs, we are sponsoring the DeFi track of Coliseum. So if you guys have any ideas or want to get building this is a great opportunity. If you guys are, reach out to us so we can provide support, ideas, resources to make sure you guys' products and submissions are as good as possible. And then on the side, we also have a 20,000 USDC sidetrack on Super Team Earn right now, which is running in parallel to Coliseum. So even if you're submitting to Coliseum, you can also submit here. And we're also working really closely with some of these teams to make sure that these products and applications are super optimized. And our goal really is that most of these apps, and especially some of the hackathon teams, can launch with us for mainnet alpha, which we're close to shipping here soon. So obviously Kahoot is a great example that came out of our fellowship. I don't know, maybe Sayatama has some feedback for us on how that went and how his experience was, but we're really, really trying to work closely with all the devs and teams that are using Arcium to make sure that, this stuff is really usable and privacy isn't a bottleneck anymore, but really a catalyst to open up a completely new design space on chain. So please reach out. There's a lot of opportunity in the Arcium ecosystem right now. If you guys are interested or already building something.
Yeah, thank you, Alex, and thank you for everyone watching this workshop. And have any question for me, for Ariane, for Alex, and for about dev, about problem, and about hackathon, net hackathon, and opportunity for in Arcium ecosystem. Yeah, have any question? Okay, and I know Ariana have he uh, allow me as a BITS learning course. Yeah.
Yeah. Um,
You can say something about to how you build on Web3.
yeah. Yeah. So, I mean, if you want to sort of build with Arcium, I mean, it's basically as simple as building normal Solana programs. The two things I would take into consideration is why you need privacy, where do you need privacy, and sort of try to isolate your business logic, your user workflow with respect to how privacy plays into it. Um, that will help you or anyone, it will help you out understand how you want to structure your programs and build with Arcium. Because one thing that I've seen that a lot of devs are trying to build with Arcium is that they sometimes face issues trying to decouple their normal business logic and the business logic that needs to run on encrypted data.
Yeah.
That's something important, and it's not that hard. It's basically just you gotta sit down, write your user flow, write down how everything will work, and then on a piece you can just take a pen and paper and do that, and then you will be able to understand. Okay, I need to have this thing encrypted, but not this, right? Because not everything needs to be encrypted. Not everything needs to be run on computer on encrypted data. You need to optimize your workflows as well in order to make sure that you're not supplying too much data as well. People tend to forget when working with Arcium that there's only 1232 bytes. That is approximately 1 kilobyte of data in a single Solana transaction, right? So you can't just go around and say, hey, I want to encrypt 10 different data points and then compute on it, because currently every data point converts to about 32 bytes after encryption. So 10 data points means 320 bytes, which is already now 1/4 of your entire transaction data available, right? So these things add up quite easily. So it's better to structure it, plan it out, see what the limitations are, and how to work within them. if anyone has any issues around it, feel free to DM me. My DMs on Twitter are open. Also, if you want to understand more about how some slightly complicated applications with Arcium would work like, um, yeah, so you can then basically just try to look at the blackjack example that's there, because that's, I would say, a fairly complicated example, and understand how it works. And if you once you do, it will be much more easier for anyone to build with Arcium.
Yeah, thank you, Ryan. Yeah, and have question. What workflow tool would you recommend to visualize business logic and encrypted pattern or project? Yeah, I
Yeah,
think
workflow. I mean, so that basically depends on two things, right? One, it depends on actually it only depends on one thing. What do you want to do, right? What is your goal when building your application? What do you want to keep private? How do you want to keep it private? What do you want to compute on that private data, and how it affects your end user? These are the things you need to understand in order to sort of mold your way into building what's needed to be built. So there might be a case wherein you're storing some user data, or let's say some game data, right? Not all metadata should be encrypted. There might be some. So, for example, blackjack, right? I don't need to encrypt how many rounds of blackjack have been played or what the current betting amount is, unless that's the goal of my application. If my goal of the application is just to build on-chain blackjack with transparency, I can keep the betting amounts, the current pot, all of that public. All I need to encrypt is the hands, right? The dealer's hand, my hand, other player's hand. So all you need to do is to sort of narrow down what your ideal goal is when building your application, and therefore relating to that encrypt data effectively. Because at the same time, you need to understand there is a trade-off that you're making every time you're encrypting a data point. You're increasing the size of it. You're increasing there's more added data that you need to transfer, transmit. Yeah.
okay. Um, okay, and encrypted data is very important for everyone. And now, thank you for watching, and thank you, Ariane. Thank you, Alex. Got to join this workshop tonight. Yeah, thank you, everyone.
Thank
Thank
you
you
for having
guys.
us.
Yes, goodbye,
Bye.
and good night.